Section 10.2 deals with converting from a radical expression to a rational exponent. So a radical expression, right, is like an example of that as a square root. So here we have the index number n, so the nth root of a to some exponent m. What we can do is we can convert this into an exponential notation, and we can go back and forth between the two, depending on whatever helps us, whatever's more appropriate. Our index number becomes the denominator of our exponent, and the exponent number becomes the numerator of our exponent. So first we're just going to show how this is used, right? When we have this first example, we're asked to evaluate 64 to the power of 1/2. Now the power of 1/2 is not something that we are really used to. That's not a very common representation or common simplification. So instead what we want to do is we want to represent this as a radical because we can more easily evaluate radicals. So here we have 64 to the power of 1/2. So first we want to identify the index number. And the index, again, is going to be the denominator of our exponent. So here our denominator is 2. So this is going to be a square root, which I don't necessarily need to have the 2 out front. That's implied, but I'm just going to write it for the sake of showing where it goes. And then the exponent 1 becomes the exponent of the inside. So this becomes 64 to the power of 1. So again, we don't necessarily need to have the 2 on the outside. So I'm just going to rewrite it, the square root of 64, because we don't need to have the 1 as the exponent either. And then we can evaluate this. The square root of 64 is simply 8. Now likewise, well, that's how we use it. So what we can also do is we can use that to convert back and forth between radicals and rational exponents. So here it says just rewrite as a radical expression or as a rational exponent. So here we're starting as a radical expression, so we want to rewrite it as a rational exponent. Our base is going to be the same base that we have here, y. The index number is going to be the denominator of our exponent, and the exponent within our radical is going to be the numerator of our exponent. So the fourth root of y to the power of 3 is rewritten as a rational exponent of y to the power of 3/4. There we go. So that's rewritten as a rational exponent. Likewise, we can go ahead and rewrite x plus 2y to the power of 3/7. Oh my. There we go. Okay, so again, we want to ask ourselves, well, what is the index number? The index number relates to the denominator here. So we know we're going to take a 7th root. The numerator in our fraction is the new exponent. So we have x plus 2y to the power of 3. And we're just asked to rewrite it, so that is as far as we're going to go.